Hello and welcome to another Build With Me video. This time we're going to be building this multi-coloured, well, I'm going to call it a nightlight because that's ideally what it is for. I also build a 3D printed case for it, and the files of course are in the description below for this. Let me just take the covers off this and turn the lights on a little bit so you can see what this is about. Watch your eyes. So it is simply a whole bunch of 10mm RGB LEDs arranged into a pattern, or you can keep them all flat if you want, and of course the circuitry on the back. This is a kit, at least the circuit board and all the components are a kit. It's very reasonable. Link for it will be down in the description below. And then I 3D printed a base and also a diffuser or lid for it as well. It has a number of different modes. So let's see what comes in the kit. A little bag of RGB LEDs, bag of components, circuit board, and a USB lead. These look like 10mm RGB LEDs. A little bag of components. Let's see what all we get. Some SMD resistors, SMD cap, some more surface mount components. In fact, all of the components are surface mount, even the USB socket. I'll bring you a bit closer to have a look at the components and also a closer look at the circuit board. So here we are with a bit of a closer up view of what is remarkably few components for this particular kit. We have of course got our microprocessor. Comes pre-programmed, so you don't have to program it yourself. Then we have a whole bunch of resistors. 1, 2, 1. That's 120 ohms. These are current limiting resistors for the LEDs. They give us two capacitors here. These, actually there's only one on the board, so you've got a spare to lose. And the same with this 105 resistor, that's 1 0 and 5 zeros, 1 meg ohm. There's only one of these on the board, but they've given you two. Main decoupling or reservoir capacitor, so again surface mount. And then our USB connector, again surface mount. It has a couple of little pegs that you can just see there and there. They go into the circuit board to provide a bit of mechanical stability, but that potentially will be a weak spot. I may actually also add some glue underneath this as well. And then we've got some hardware, 3 little standoffs and corresponding screws. But I intend to 3D print a case for this, so these screws and standoffs may not actually be used. Let's have a look at the circuit board. So this actually is the underneath of the circuit board. All the components that we saw, all the surface mount components go on the underneath of this circuit. So obviously this microcontroller in the middle, and then we've got all the resistors for the LEDs scattered around. Main reservoir capacitor here. That'll be on the other side. We have our touch pad, and then all of the LEDs, RGB through-hole LEDs, get mounted from this side. And this will be the top side of the finished product. So quite a neatly laid out circuit board. Yes, it's in an annoying white solder mask, but then because this is going to be for lights, it's actually a good thing because it will just reflect that light. There also is instructions that are supplied, linked to from the main purchase page on Banggood. These are reasonable quality instructions, but of course they are translated. As you can tell here, we've got all of the chip resistors, €120. Well, no, that would be a very expensive resistor. They're 120 ohms. So there's about 8 pages. I printed them out 2 to a page, and it gives you some basic instructions. This is a kit that is probably most suitable for not a very much beginner at soldering, because the surface mount components are not always that easy if you're just new to soldering. And the same with these RGB LEDs. The leads are very close together. It's very easy to get solder bridges. No doubt I will show you that in effect as we build it together. So let's move on to actually putting some of this together. So where to start? Well, I normally start with the smallest number of similar components. By that I mean we've only got 105 or 1 meg resistor. There's only one on the board, and it's R22. All the other resistors on this board are 120 ohm. So this is the only one of this kind that goes in R22. So best to do that first, and then I'm going to do the capacitor C1 over here. Again, that's the only one of that value of capacitor. Put that in, and then there's no mistaking and accidentally putting the wrong component in. That's what I like to do anyway. So I'm just going to put a bit of flux on here. Flux really does help. It's essential, really. It means that you can actually just put some solder onto your soldering iron and bring that to the component as it's positioned. There it is. Simple as that. If you don't use flux, it's much more difficult. Let's just move this round. I find working at an angle is helpful for surface mount. Again, a little drop of flux. Bring our capacitor in. And that's those two unique components put in place. Now you can very happily go ahead and work on any of these other similar sized footprints, knowing they're all the same component. There's not a problem about getting things mixed up. So let's just try and dig into this and get some of these resistors out. I've got a bunch of these resistors out on my worktop. We can just put a few drops of flux on the board. If it doesn't quite take, it's always good just to check by trying to move the circuit board by the component you just soldered in. And then if the whole thing moves, you know it's been soldered in okay. Or if the component moves off, then you know you need to do it again. So that, I think, is all of the resistors. Just have a quick look through to make sure I have soldered all of them on. Yep. So next up is our integrated circuit. Of course, on the silk screen we've got the little dot and also the notch indicating the dot indicating pin 1. Of course, on the package itself it's got this little indentation. Some of them also have a little notch here, but this one doesn't appear to have that. So for this we again use plenty of flux. So we've got it into position, and then we just do tack a couple of leads. Need a bit more solder on my iron. Oh, that didn't quite take onto that. Bit out of position for that one. And turn the board round, and then give it just the right amount of flux. And then we can do that. Try not to put too much heat into one side at any one time. But don't be afraid of using plenty of flux. Flux is your friend. Don't worry if you get a solder bridge, just put a bit of flux on, clean your soldering iron and drag it away. If you wonder where all that flux was going, onto my bench. The answer. It'd be terrible to get to this point and realise I put the circuit in upside down. no, we're okay. We've got the dot. And then you can just see underneath the sill screen there, we've got the notch and also the dot to indicate. So it's always good just to double check your work, and at this sort of tininess of component, it's good to check it under a microscope if you can, or magnifying glass, just to make sure, yeah, we've got all of that. Right, we've only 2 surface mount components left, so we're going to do the USB socket. So this actually has got solder tabs either side for mechanical strength, so that's good. Probably won't have to glue this down.